In this video, we are building a full RAG application from absolute scratch. RAG stands for Retrieval Augmented Generation. It's the technique behind every AI chatbot that can actually read your documents, your data, your knowledge base, and answer questions from it accurately. No hallucinations involved, no outdated info, just answers grounded in your own content. We're going to start from the very basics. I'll explain exactly how it works visually, no jargons involved, and by the end of this video you'll have a real working app where you can upload a PDF and chat with it as well. Concepts, code, full backend, chat UI, everything is included in this single video. So let's get started. And if you find this interesting, please do the like button and do subscribe for more such content as well. So let's get started with the video. So you might have used ChatGPT, obviously. You've asked it things, and at some point it might have given you a completely wrong answer, and that too very confidently. Maybe it got the date wrong, or maybe it didn't know about something that happened last month. Maybe it just made something up. So that's actually not a bug. That's actually how your LLMs work. So they're trained on data up to a certain point, and after that they're essentially blind. But what if you could, give an AI the ability to read your documents, your data, your knowledge base, and answer questions from that in real time, that too accurately? That's what exactly your RAG does. And by the end of this video, you're gonna build it yourself. So RAG stands for Retrieval Augmented Generation, as you've discussed earlier. So these are the three words, and we have one simple idea. So instead of asking the AI to remember everything, you give it a search engine over your own data right before it answers. So think of it like this. Imagine you're taking an open book exam. You don't need to memorize the entire textbook. You just need to know how to find the right page fast, read it, and write a great answer. That's what drag exactly is. The AI finds the relevant chunks from your documents, reads them in the moment, and uses them to generate a grounded, accurate response. No hallucinations involved, no outdated knowledge, just answers from your data. So, companies are actually using this right now. So, let's say a customer support bot that reads your product docs, a legal assistant that searches through case files. All these are examples of RAG. And let's say a personal second brain that answers questions from your own notes. So, this is one of the most demanded skills in 2026, and it's actually not that hard once you understand the pieces. In this tutorial, we'll go from zero to a fully working RAG application end to end. We'll start with the core concepts, that is embeddings, vector databases, chunking with zero code, just visuals, so you actually understand what's happening under the hood. Then we'll write our first RAG system in about 30 lines of Python. You'll see it work in real time as well. Then we'll go a little bit deeper, that is understanding about loading real PDFs, handling chunking properly, building a full fast API backend with a Streamlit chat UI that you can actually use. And we'll finish with how to make your RAG better, because the first version always has problems, and I'll show you exactly how to fix them. So let's get started with the core concepts of RAG. Okay, so before we write a single line of code, I need to explain three things. And I promise once these three things click, everything else in this video will make perfect sense. So the first one is called something called as embeddings. And it sounds scary, but it's actually one of the most beautiful ideas in all of AI. So let's understand this. So here's the problem. Computers don't understand words, they only understand numbers. So, how do you teach a computer what the word king means, or pizza, or sad? The answer is you turn every word, every sentence, every paragraph into a list of numbers. That list of numbers is called an embedding. But here's the magical part: the numbers aren't random, they're chosen in a very specific way so that numbers with similar meanings get similar numbers. So, the analogy is simple. Think of it like a map. Imagine a giant map of all words in the English language. On this map, similar words live close to each other. For example, happy and joyful are right next to each other. Dog and puppy are neighbors. King and queen are close, but king and pizza are on a completely opposite sides of the map. So that map, that's the embedding space we're talking about. So every word, every sentence has a location on that map, and the location is just a list of numbers, that is its coordinates. So when we say turn text into an embedding, we are saying take the sentence and figure out its coordinates on that giant map. Okay, so and once everything has the coordinates, we can ask which chunks are closest to my question. So let's say if at all your question is what is the return policy, that question gets the coordinates, and then we find the chunks in our documents that are closest coordinates. That's retrieval. That's your R in RAG. So let's understand another simple analogy. So here's another way to think about it. So you know how Spotify recommends songs that are similar to ones you like? It's exactly doing the same thing over here as well. It's mapped every song into a space of numbers, tempo, your mood, energy, genre, and it finds songs that are close to the ones you love. Embeddings do the same things, but for the text part. So, to summarize embeddings in one sentence, so basically your text goes in, a list of numbers come out of it, and similar text gets similar numbers. That's it. That's how your embeddings work. And that's all you actually need to know for now. So let's move on to the next part, that is going to be vector databases. Okay, so now we have learned about embeddings, that is list of numbers for every chunk of text, but we have a problem. So let's say if you have 200-page PDF, you might have 1,000 chunks, right? And each chunk is a list of, let's say, 1,500 numbers. So, where do you store all of that? And how do you search through it fast? So, now let's understand the analogy of this. So, you already know what a regular database is. It stores in the format of rows and columns. You search by exact match. For example, give me all the usernames which equals Sujan. So, it just goes into the database and then finds that name and then returns that value. Whereas a vector database is different. Instead of exact match, it actually searches by similarity. So it says, give me the five chunks whose numbers are closest to these numbers. So you can think of it like a librarian who has read every single book in the library. You walk in and say, I'm looking for something about a dog that goes on an adventure. And instead of doing an exact keyword search, the librarian thinks, which books feel closest to that vibe, and she hands you the right ones in 2 seconds. So that's a vector database. It stores your embeddings and finds the nearest ones blazing fast, even across millions of chunks. So now in this tutorial, we're going to use something called as ChromaDB. It's basically free. You can actually go and check out the docs. So this one runs locally on your machine, zero setup required, zero account needed, and it's perfect for learning. So in production, people use things like Pinecone, VV8, or PG Vector, but we don't need any of that as of now. So ChromaDB does everything we need. So let's do a quick recap. So vector database in one sentence, it stores the embeddings and finds the most similar ones fast. That's the whole job. Now let's move on to the next concept, that is called as chunking. So this is one of the concept that trips up beginners the most, but it's actually super simple once you understand how exactly it works. So imagine you have a 100-page PDF. Can you just dump the entire thing into the embedding model and store it as one giant embedding? Absolutely no. And here's why. So first, embedding models have a limit on how much text they can process at once. You can't feed 100 pages. So second, and this is the bigger reason basically. So if you have stored the whole PDF as one embedding, when someone asks a question, you retrieve the entire 100-page PDF and dump it all into the prompt. That's actually way too much, right? So the AI gets confused, the answer is bad, and it costs you a fortune in tokens. So instead, you split the document into small pieces first. These small pieces are called chunks. So you can think of it like a newspaper. You don't hand someone the entire newspaper. When they ask what happened in the cricket match, you find the sports section, find the match report, and hand them just that page. So, chunking is how we create those individual pages from the document. So, when a question comes in, we can retrieve just the right pages instead of the whole paper. So, now, how big a chunk should be, right? So, this is one of the most important decisions in RAG, and there's no perfect answer for this. But here's the rule of thumb: if it's too small, you actually lose context. A chunk of just one sentence might not have enough information to answer anything. If it's too big, you bring in too much noise. You're giving the AI a whole chapter when it's only needed one paragraph. The sweet spot for most use cases is around 300 to 500 tokens per chunk. That's roughly 2 to 4 paragraphs. So there's one more thing about chunking that is called as overlap. So imagine a document has a sentence that starts at the end of one chunk and finishes at the start of the next. If we split exactly there, we lose that sentence. It's half in one chunk and half in another, and neither chunk makes sense. So we add an overlap. Each chunk shares some text within the chunk before and after that, like a Venn diagram. This way, no sentence ever gets lost at a boundary. Now let's understand the two pipelines in RAG. Okay, so an offline pipeline that runs once and an online pipeline that runs every time someone asks a question. So the offline pipeline is take a document, split it into chunks, turn each chunk into an embedding, store those embeddings in a vector database. You do this once and it's completely done. That's your entire offline pipeline. Whereas the online pipeline is someone asks a question and you turn that question into an embedding, search the vector database for the chunks with the closest embeddings, take those chunks and inject them into your AI prompt, and the AI reads those chunks and generates an answer. That's it. That's your entire RAG system. So, two pipelines, three concepts, and one beautiful idea. That's what we are currently learning about. Alright, so enough done with the theory part. Let's get started with the coding bit of it. Alright, so now let's get into the coding part of it. So, first of all, we'll be understanding what exactly is embeddings. We'll be writing a small piece of code snippet and we'll understand how exactly it works. So, you would be understanding in a better way once when we implement the RAG programming part. Alright, so first of all, I've just created a fresh new folder. I've opened up my VS Code and I've created a folder called as RAG tutorial, and I've executed some commands to install some dependencies, that is OpenAI, ChromaDB, python-dotenv, PyMuPDF, FastAPI, uvicorn, and python-multipart and Streamlit. So these are required for the entire video, whereas for now we just need just a few dependencies, that is ChromaDB and then OpenAI, to understand your embeddings part. So just make sure to create this, or you can basically create a requirements.txt file, and then within that add all of these dependencies and then just try to execute this. Automatically it should be installed. I've just executed this command. You can take a look at it. Okay, so this should be able to install all of the dependencies so that we can start working on this. So you can take a note of this command. I'll be also creating a .env file as well, where I'm going to insert my OpenAI key. And apart from that, so the first thing we're going to do is we're going to create a folder. So for that, I'm just going to say step 1 underscore basics. We'll say new folder, step 1 underscore basics. Within that, I'm going to create your embedding.py. Okay, so let's start writing the code and then let's understand what exactly is going to happen over here. So here we'll be coding out just to understand what does an embedding actually look like, so it becomes easy once you get into the RAG programming part. So first of all, onto the top, I'm going to import a bunch of dependencies. I'm going to say import OS, import your .env from .env. Let's try to load the .env. I'm going to say import load.env, and from your OpenAI package, let's import your OpenAI. So the import statements are done. So now let's try to load the .env. Okay, so for that we need to just call that. I'm going to say load.env. So the environment variables from .env are going to be loaded. Next here, I'm going to initialize my client. I'm going to say it's going to be equals to your OpenAI. It's going to take in the API key. That is going to be os dot, we do have the getEnv method, use that. This is the one, and here let's try to have in the key. That's going to be OpenAI underscore API underscore key. Okay, so that was it about the part 2. We just tried to load the API key, and we have just implemented the os.getEnv of the OpenAPI key. So this basically fetches the API key safely from your .env file. We can try to add that value over here, and to get it, I'll just show you how to do that once we have finished writing the code for this block. Now here let's try to embed two similar sentences and one different one. So for that, I'm going to initialize my sentences array that's going to contain 3 lines. So we have 2 similar ones. So as you can see, first was similar, the third one is completely different, which says the quarterly earnings report is due. Okay, this part is done. I'm going to create a embeddings array over here. So I'm going to say embeddings is going to be equals to initial empty array. So here I'm going to make use of my for loop. So here I'm going to say for your sentence in your sentences. So that's the syntax. So we're going to loop through each sentence one by one. Okay, so the first sentence is going to be your the dog ran across the park. So within the first loop, within the first statement, we're just going to say response is going to be equals to client.embeddings.create. We are trying to create an embedding. So let's understand that. Here I'm going to say your response response is going to be equals to your client dot, it's going to be your embeddings dot, it's going to be create. This in turn is going to take in 2 things. That's going to be the input, that is going to be the sentence that is coming from the loop, that's the first sentence, and we're going to pass in a model. Let's say we're going to use the text embedding 3 small. This is from GPT itself. So let's try to add that over here. Okay, pretty simple. So embedding is a list of numbers, as we have previously discussed, that is representing the meaning of a specific text. So in our case, it's going to represent the meaning of this specific sentence for the first time it runs the loop. Okay, and these numbers are actually called a vector. So why numbers? Because computers understand numbers, that is math, better than your English language. So AI converts meaning into the mathematical coordinates. I think we have already discussed this in the starting point of the video, so it becomes easy for you to understand while we are doing the coding. So that's the simplest way of creating your embedding. So after that, the next step is to extract the embedding. I'll just be entering the lines for that, and I'll also be printing the values as well. Okay, so there you go. So once the extraction is done, I'm going to say embedding is going to be equals to response.data of 0.embedding. This is the way we try to extract the embedding. Okay, this gives the actual vector, and I'm going to say embeddings.append to embedding. Pretty simple, straightforward. Just try to add it into the embeddings array, and then just show the sentence, that is the first sentence in the loop. That's going to be the dog ran across the park, and here I'm trying to show the embedding itself, that is whatever value it has generated, and this is the length of the embedding. Okay, it's pretty simple. So that's what we're gonna do. So first one is extract, then store the embedding, and then we are doing the printing of information. Okay, so the reason I've used here .4f is it basically formats number to your 4 decimal places. That's the reason I've used .4f over here. Alright, so now the next step is let's try to measure the similarity between them. So for that, we're going to use something called as the dot product. Okay, higher equals to more similar. So here I'm going to define that function. So I'm going to say define your dot underscore product. This is going to take in 2 values, a and b, to compare. Here I'm directly going to say return your sum. Over here I'm going to say x multiplied by y. For x, this is the mathematical formula. Here I'm going to say y in zip of your a comma b. Okay, that's it. So first of all, let's understand what is your dot product. So that's basically a mathematical operation. It usually compares 2 given vectors. That's what we're doing in our given case. So the intuition is simple. That is, if at all 2 vectors point in similar directions, then we have a high score. If unrelated, then we have a low score. So that's the reason we are trying to use this function, that is the dot product. So below this, let's try to just initialize the similarity part, and then let's try to call the function. So I'm going to have 2 variables. There is sim12 and then sim13. We're going to call the dot product, and we're going to compare embedding 0, embeddings 1, and embedding 0 as well as embeddings 2, just to check out the similarity part. Okay, and below that, we're going to show all of the print statements. So let's try to add that. I'm going to add all of the print statements over here. So there you go. I've just added all of the print statements. It's pretty straightforward. You can try to look at it. So now, yeah, the first output is going to show the similarity sentence 1 versus sentence 2. That is going to be with respect to this one. So we're just trying to call the value sim12. It's pretty simple, and up to 4 decimal places. So again, give .4f. Second printf statement, again, it's going to show the similarity versus sentence 1 versus your sentence 3. Alright, and we're going to call this variable sim13, and then it's going to have a different meaning. And yeah, that's the hard-coded text. Here again, we have passed in .4f. It's going to show up to 4 decimal places. Okay, again, we have just given a print statement, and over here we're going to say notice similar sentences score higher. That's embeddings working. Okay, let's give this a try and let's actually check how exactly this is going to work. So I'm going to execute python3 embedding.py. Okay, so come back to your folder. Here I'm going to say python3 embedding.py. Enter. Okay, my bad. So this is there within the step 1 basics. So I'm going to say cd to step 1 underscore basics. Here, let's try to execute that. I think I also need to paste in the key. That is for the OpenAI key. Let me just get that and then paste it over here. So I've just pasted in my key. So to get your key, head over to OpenAI, platform.openai.com, and then you should be able to log in with your Google account. Over there, go into your API key and try to add in about $3 of credit and try to create a new API key and copy it once it is available on the screen, because once it goes off, it's not going to be shown again. Copy that and then paste it into your .env file. Okay, so it's pretty simple to get an OpenAI key. You should be able to just Google it if at all you do not know how to get it. Otherwise, you can get it at platform.openai.com. You can check that out. So now let's try to run this. That is python3 embedding.py. And boom, so it's finally executed. So we are able to see the proper embeddings getting created for each of the sentence. So let's understand the output properly fine. Okay, so the model took around 3 seconds and turned each one into 1536 numbers. That's basically your embedding. As you can see, the length is shown over here, and this is the embedding array. You can see the first 3 numbers printed. They look random, like this value 0.076, 0.0023, and the third one, but they're not random at all. Honestly, every single number means something. So together, all 1536 numbers describe the meaning of that sentence in mathematical space. That's how you put it together. So now let's look at the bottom part. That's the important thing, that is your similarity part. So here it says this is the value, that is 0.5671. Similar meaning. Second one, it says 0.0488. That is a different meaning. So sentence 1 is basically the dog ran across a park, and sentence 2 is a puppy sprinted through the garden. So sentence 3 is completely different, as you can see over here. So sentence 1 and 2 are about the same thing, that is a dog or puppy running outside. So the score high, that is 0.5691. 0.5671, whereas your sentence 1 and sentence 3 are completely unrelated, a dog versus a finance report, as in this case. So hence they score a lower value, that's going to be 0.0048. Okay, so the model has never seen these sentences before. We didn't tell it anything. It just figured out a similarity purely from the numbers, and that's how your embeddings work, and that's how we compare the similarity. So yes, that's the simplest part of how your embeddings work in Python. Okay, we understood how exactly the sentences are converted into numbers, and we also checked the similarity part as well. So this was basic. So now let's get into the main part, that is building a simple RAG program, and then we'll understand how exactly the code flow goes. So hope you understood this part, that is vector databases, that is the embeddings part, and the chunking, how exactly it works. Okay, so now let's head back to the second program. So just like how we wrote a simple program to understand embeddings, now let's write a simple program to understand what exactly is RAG in coding terms. So let's understand how it works. So within the same folder, I'm going to create a new file that is going to be called rag.py. So we'll understand what this particular file is going to do. It's going to take in 5 hard-coded text chunks, turns them into embeddings using OpenAI, stores them in your ChromaDB, that's the vector store, and it takes a question as input, finds the closest chunks, and sends the question and chunks to GPT and gets a grounded answer. So that's what essentially RAG does. We're trying to implement that in coding format. First of all, let's try to import the statements. So this is going to be similar. Let's try to add it over here. Apart from that, we're also going to import your ChromaDB. Again, I'm going to say load.env, just like this. And let's try to initialize the client code. that is over here. So now the next step is to get in the documents. That is going to be hard coded for now since it's just a simple programming code. So let me just get the documents over here. So I'm essentially going to paste in the documents. It's going to contain about 5 lines, so which has information about return policies, refunds, and items that are damaged or used cannot be returned unless they are defective. So some useful lines about a company. Okay, we're going to use all of these 5 lines and then we're going to implement it. So now the next step is let's try to set up ChromaDB. It's pretty simple. It's local to the system as well. No account needed. So for that, here I'm going to say chroma underscore, let's say client is going to be equals to ChromaDB. Okay, just like this, that is ChromaDB to client. We're trying to initialize that. Next, I'm going to say collection is going to be equals to your chroma client. We do have the create method, use that. So create collection, name is going to be equals to my first tag. You can give any name you want to give. Okay, so now step 3, simple as we discussed. We're going to turn your each document into an embedding and we're going to store it as well. Okay, so here I'm just going to add a printf statement saying that embedding and storing the documents. So here I'm going to make this a for loop. I'm going to say for I comma your doc in your enumerate of your documents. So you are trying to loop through each chunk. Okay, so the next step is we are going to first of all convert the text into your vector format. So for that we're going to say response is going to be equals to your client dot your embedding dot create method. Here again it's going to be similar, taking the input that is going to be equals to your doc, that is your value that's coming from the loop. Next you're going to use the model, again similar, text embedding 3 small. Okay, so this converts your text into vector, the similar thing we have done previously. So the return policy text is going to be converted into, let's say, an array of 3 numbers. Okay, that's it. So next part, if we need to extract the embedding, that's what we're going to do. So it's going to be simple, that is embedding is going to be equals to response.data of 0 dot your embedding, just as we have done previously. Let's try to add it over here. Okay, so the extracting part is done. Now the next step is we need to store it within your ChromaDB. So for storing, we are going to say your collection. Here I'm going to say your collection dot, we do have the add method, use that. This in turn is going to take in the documents, that's going to be your doc. Okay, and your embeddings is going to be in the form of an array, that is your embedding. Then I'm going to say IDS is going to be equals to f doc underscore your index. Okay, so that's it. So now we are trying to store all of the values within your vector DB. In our case, that is your ChromaDB. So why we are using that IDS? Because every database row needs a unique identifier. So that's the reason we have passed on the IDS or the IDs. So this part is done. So next is this part is almost done. So now next part is simple, that is try to give an input field. Let's say how long I have to return something. That's the question being asked by the user. So it's going to search and it's going to give us a proper answer. So first of all, let's try to add in a printf statement after this. And I'm also going to paste in my question as well, which is going to say how long do I have to return something. So once we have pasted the question, we also need to convert the question into an embedding as well, as we have discussed earlier. So here I'm going to say question underscore your embedding is going to be equals to your client dot your embeddings dot create. Here your input is going to be equals to your question. It's pretty simple, and pass on the model over here. That's going to be again your text embedding 3 small, and here itself I'm going to say dot data of 0 dot embedding and get the value as well. Okay, so now the next step is, after turning the question into an embedding, we need to search the ChromaDB for the 2 most similar chunks, correct? So for that I'm going to say result is going to be equals to your collection dot query. Here your query underscore embeddings is going to be equals to your question underscore embedding, and here I'm going to say n underscore result is going to be equals to 2. So now let's understand that piece of code. So this is basically called as semantic search. You might have heard of this, and this is how we implement while searching. So what happens internally? So since your vectors are stored in ChromaDB, so ChromaDB compares your question vector against your all document vectors. So this is the question vector, and it's going to compare with all of the vectors it is been embedded with. Okay, so it finds the most related meanings, not with keyword matching, because this is a vector database, and this is basically the magic. So the question we asked is, how long do I have to return something? So the document has customers can return items within 30 days, so no exact keyword overlap, but the meaning is similar. So embeddings is going to solve this problem. So we also pass that n underscore results equals to 2. So this means retrieve top 2 most relevant chunks. Okay, that's the reason we've passed in that. So the retrieved chunks are going to be stored in the results. Let's try to add in that as well. And I'm also going to add in the printf statement too. So let's go ahead and then add it over here. Okay. So here I'm going to say retrieved chunks is going to be equals to results of documents of 0. That is the list of matching chunks. And just use a printf statement and then show all of the chunks over here with the help of the for in loop. So results is missing. Okay, so here it should be plural. So I'm just going to say results over here and save the file. So this part is done. So now the next step is send the question and the chunks to GPT, that is build the prompt, inject the retrieved chunks as context. So now let's try to create the context over here. I'm just going to add the code for that. Okay, so this is how we create the context. That is with the help of this line. We're going to combine the chunks into one text block. So this is an example context. Okay, so we're going to say the return policy allows customers to return items within 30 days of purchase. All returns must include the original receipt and packaging. So this is how we're going to build the prompt. We're going to say you are a helpful assistant. Answer the question using only the context below. If the answer is not in context, say I do not know. Okay, so your context is basically going to be all of the texts that are retrieved over here. That is with the help of this line. Okay, so context we are trying to pass over here with the help of this. The question is the question asked by the user, that is hard coded. This is the value. Okay, and this is the response. So we're going to say client.chat.completions.use the create method. I'm going to use this model, that is GPT-4 Omni, and we do have a messages array that's compulsory to pass, which is going to take in the content, that's the prompt, and role is going to be of the user. Alright, so this basically prevents your hallucinations, and that's how RAG works. And why are we giving the prompt? It's pretty simple, because without this instruction, GPT may invent its own answers and give some random answers that might not be correct for a particular company. Okay, in this case, we are particularly asking GPT to use the context and only answer from that part. Okay, that's these values. So yes, that's it. So this part is done. So finally, it's going to give us a response. So we need to say answer is going to be equals to your response dot your choices of 0 dot your message dot access the content. And once that's done, we can try to print your question as well as the answer. So use the printf and then show the answer as well as the question, just like this. So that's pretty much it. Let's try to execute this. So it's gonna be simple, python 3 your rag.py. And boom, just like that, embedding and storing documents. As you can see, stored 5 documents in ChromaDB for all of these values. And these are the retrieved chunks. As you can see, the return policy allows customers to return items within 30 days of purchase. As you can see, it's currently referring to this particular context and then retrieving the chunks. And items that are damaged or used cannot be returned unless they are defective. So since we have passed the end result is 2, it's gonna get the top 2 matching values. So it's printing the values over here. That is, how long do I have to return something? Answer is pretty simple. You have 30 days to return something that is returned by your AI, that is GPT in our case. Okay, so as you can see, this part is working properly fine, and this is the simplest example of how a RAG is gonna work. Okay, so now the next step is the final part of building a simple kind of RAG application, which is going to be powered by a FastAPI. It's going to have a simple front end, back end as well, and we're going to implement all of the other functionalities as well. That's going to be the next step, and the final step, you should be able to understand what exactly is RAG, and you should be able to code out your own kinds of applications. So let's get started into building that RAG application. We're going to have a different folder structure and we're going to start building this one. So now we're going to build a simple kind of RAG script that is going to be a Python script, no server, no UI. You can run it once from the terminal. It's going to read a PDF, it's going to chunk it, embed it as well, and prints the answers directly over here in the terminal. So this is just for the learning part, so you can understand the PDF ingestion process and the chunking logic in isolation before building the entire application. Okay, so after this we're gonna include the another folder where we're gonna have the backend as well as the front end. Backend is gonna be FastAPI, front end we're gonna use the simple Streamlit. So yes, let's first of all complete the simple kind of RAG program where we're gonna use a PDF. Okay, so for that let's create a file that is gonna be a rag.file. So let's create a step2 folder. Okay, not within this, onto the root level, press on env, new folder, I'm going to say step2. Within this I'm going to say rag pdf.py. Okay, so here let's start writing all of the code. So what this file does, it's basically going to read a real PDF file using your PyMuPDF package from Python. So it's going to extract all of the text page by page. It's going to split it into chunks with the overlap, and it's going to embed and store each chunk with the metadata. So over here, first of all, let's again import all of the required things for the RAG PDF file. So first of all, import OS, import fits, then import your .env from load.env, and then import OpenAI from OpenAI. From OpenAI, import your OpenAI. Next, let's try to load the env and then initialize the client. It's going to be the same code essentially. Add it over here. Next here, let's try to have in the PDF path. So make sure to get your own kind of PDF and then just paste it or place it within the step2 folder. I'm going to add that later. We can enter the path. It's going to be something.pdf. I'm going to say chunk size. That's going to be characters per chunk. So here I'm going to pass in 500. Next, there is something called as chunk overlap. That is characters of overlap between the chunks. Okay. So I'm going to say chunk underscore overlap is going to be 50. Next, let's try to first of all extract the text from the given PDF. Okay, so here chunk size means it's going to contain, your each chunk is going to contain 500 characters. So why chunking exists? Because LLMs cannot efficiently process entire books, your giant PDFs, huge documents. We already learned that at the starting point of the video. So we essentially try to split them. Okay, so instead of entire 200-page PDF, we're gonna split it into your chunk 1, chunk 2, and then chunk so on. All right, okay, so that's it. So now let's move on to the next step. That's going to be extracting text from the PDF. So for that, let's first of all write a function. So here I'm going to say define extract underscore PDF or text from PDF of your PDF underscore path. Okay, so this can be small letters itself. Alright, so that's the way we try to initialize the function. The next step is to first of all open the PDF. So for that I'm going to say doc is going to be equals to your fits dot, we have the open method, use that and pass on the PDF. That's going to be PDF underscore path. That's going to come from the function parameters. So this basically loads the PDF into memory. Now next, let's initialize the pages array. Okay, where the storing is going to happen. So I'm going to say pages is going to be equals to empty array. So this is basically going to store the page number and the text. All right, so first of all, let's try to loop through the pages. That's the next step. Here, make it to the for loop for page underscore number comma your page in enumerate of your doc. So here essentially we're going to try to extract the text. Text is going to be equals to page dot, we do have the get underscore text method, use that. Okay, that's going to be just like this. And I've also entered the strip part. That's going to be for cleaning. It removes the spaces as well as the new lines. And we're also going to skip the blank pages. Okay, so we're going to check the condition stating that if text is present, here if text, I'm going to say pages dot your append of your page number plus 1 comma the text. Okay, so that's it. Next we can try to close the doc. So here I'm going to say doc dot, we have the close method, use that, and we can try to implement the printf. Okay, just show the message that is going to be just like this. Okay, so this part is done. So now the step 2 is going to be for chunking, that is split the text into chunks with the overlap. So for that also we're going to have a function. Let's define chunk underscore text. This in turn is going to have your text and your chunk size, and it's going to have your overlap as well. So yeah, let's understand why chunking is necessary. Because embedding giant documents is bad because it's expensive, it's slower as well, and retrieval becomes inaccurate. Okay, so first of all, let's try to initialize the chunks array similarly how we did it for the pages. So chunk is going to be equals to the empty array. So let's have in a start position, that's going to be start equals to 0. So this basically tracks where the chunk is going to begin. So yeah, start is going to be equal to 0. Let's try to loop over here. I'm going to make use of a while loop. I'm going to say while your start is less than length of text. Okay, so this is basically going to continue until all the text is processed, and end position is going to be equals to your start plus your chunk size. So end equals to start plus your chunk size. So let's say example, so 0 to 500 and then 500 to 1000. Okay, so next let's try to create the chunk. So chunk is going to be equals to text. So this basically is going to get your substring. Once this is done, we're just going to append it to the array. So it's going to be chunk dot append of your chunk. That's it. Now let's move forward with the overlap. So this is very important. So here we're going to say start plus is going to be equals to, so basically we move forward by chunk underscore size minus the overlap. Okay, so this ensures the next chunk shares the same text with this particular one. So for that over here, I'm going to say start plus is going to be equals to your chunk underscore size minus your overlap. That's it. And yeah, let's understand the example over here. So let's say your chunk size equals to 500 and the overlap is equals to 50. So the movement is going to happen like this. Equals to 500 and your overlap is going to be equals to 50. Let's say that's the value. So your movement is going to happen something like this. Okay, so chunk 1 is going to be from 0 to your 500. Okay, and similarly your chunk 2 is going to be from 450 to 950. Okay, that is 50 characters are repeated. All right, so why does this matter? Because important sentences may sit at chunk boundaries and overlap preserves the continuity part. So that's the reason we have written it like this. So once this is done, we can directly try to return the chunks over here. So let's say over here, return chunks. That's it. This part is done. So now the next step is to embed the chunks in batches. That is the faster and the cheaper method. Let's try to define that function real quick. I'm going to say define embed underscore your texts of your texts. Okay, so what this is going to do, so this is going to basically embed multiple texts together. So first of all, we're going to implement something called as batching. Okay, so instead of one API call per chunk, we do 100 chunks in one API call. So this is basically much faster, cheaper, and production ready as well. So for that, first of all, let's try to create your embeddings. So I'm just going to add the code for that. So here it's going to be simple. So we have already written this code n number of times. So just use the client.embeddings.create input text and pass on the model from GPT, that is text embedding 3 small. And here we're going to say return item.embedding for item in response.data. Okay, so it basically returns an array in array with all of the embeddings that is in the form of numbers. This part is done. The next step is important, that is store everything in ChromaDB with the metadata. For that, we're going to use a index PDF functionality. Let's go ahead and then write that. Here I'm going to say define index underscore PDF of your PDF underscore path. Okay, so this is the main ingestion pipeline. So let's try to write the persistent ChromaDB. So here we're gonna have the Chroma client being initialized. So Chroma underscore client is gonna be equals to your ChromaDB dot, we do have the persistent client of your path, that is gonna be dot / chroma underscore db. So at the top, let's go ahead and then import that. That's required. That's import ChromaDB. Okay, so yeah, this part is done. Now the next step is, if at all any collection is already present, let's try to delete that. So let's try to have a try block over here. So here we're going to say chroma underscore client dot, we're going to say delete a collection uses method and pass on the PDF over here. Okay, so that's going to be PDF underscore rag. Next, except we're going to say pass. This part is done. So yeah, after this, first of all, we're going to initialize the collection. So here I'm going to say collection is going to be equals to your chroma client dot create collection of the PDF. That's going to be PDF underscore rag. So next, below this, I'm going to have in all of my storage arrays, that is for all chunks, all metadata, all IDs, and I'm going to initialize the chunk index to be of 0. Okay, so next let's loop through the pages. So here I'm going to say for your page number comma your page underscore text in your pages. Okay, so pages is not defined. Yeah, I think this should come below the collection part. Okay, so this is going to basically extract the pages from the PDF. So let's continue with this one. So here, first of all, let's split the page into chunks. That's the next step. So chunk is going to be equals to chunk underscore text of your page underscore text for each page in the PDF. Next, skip the tiny chunks. So for that, I'm going to check the length basically. That is, if your length of chunk dot. So next over here, I'm going to add in all of the append lines for all of these ones, that is chunk, your metadata, as well as the chunk index. So this is going to be all chunks dot append of chunks after it is being extracted. So the metadata part is important because each chunk remembers the source PDF, your page number, and the chunk number. That's what we've written over here. Okay, next let's try to embed in batches. Okay, so we're gonna have a batch size of 100. All right, so let's try to add that over here. Batch underscore size is going to be equals to 100. Next, you're going to try to loop through the batches. That's the next step. Here I'm going to say for I in range of 0 comma your length of all underscore chunks comma your batch size. Okay, here first of all, this is going to process the chunks in groups of 100. We're going to embed the batch. Embeddings is going to be equals to embed underscore texts of your batches or of your batch. Okay, so I've added the remaining code as well. So all embeddings is not defined. Yeah, I think we need to add the array for that. Yeah, so all embeddings is going to be equals to empty array. So make use of the for loop and then add the remaining part. Here it's going to say embedded batch for that particular value and the batch size +1. Here it's going to show the length of the batch and for that chunks. Okay, so this part is complete. Next, we store everything in ChromaDB. Let's try to add that. So we're going to say collection dot we do have add. This in turn is going to take in the documents, that's going to be all underscore chunks, and your embeddings, that's going to be your all underscore embeddings. Apart from that, it's going to take in the metadata as well. So metadata is going to be all metadata. IDs is going to be all IDs. All of them have been defined. So this part is done. So there you go, just like that. And I'm also written a print f statement that is done. Indexed length of all chunks from your PDF path, and return the collection. So this part is done. So now the next step is for the querying bit, that is to ask the questions. So this is your retrieval pipeline. So let's try to write the function for that. I'm going to say define ask of your collection, comma your question. So the first thing we're going to do is we're going to first of all embed the question. So here I'm going to say question underscore embedding is going to be equals to embed underscore text of your question of 0. Okay, next is to search for the ChromaDB part. That's going to be the vector search. So here I'm going to say results is going to be equals to your collection. We do have the query method, use that. Here we're going to say query underscore embedding is going to be equals to question underscore embedding. Again, we're going to pass in the end results as we have done previously. So end results is going to be equals to n underscore results. That's going to be equals to 3. Let's pass it as a parameter over here. Okay, so once after that's done, we're going to say include equals to array of string, that is going to be your documents, your metadatas, and your distances as well. Okay, so yeah, that's pretty much it. So basically your ChromaDB is going to compare your question vector, your all chunk vectors as well, and we have passed in the end results as 3 because we need to retrieve the top 3 chunks. And we also need to, and we also have included the extra data as well, that is all of these 3 things. Okay, so this is done. Here let's try to show all of the required details, that is for the chunks, metadata as well as the distances. It's going to be results of documents of 0, and then metadata of 0, and then distances of 0. So this is going to display all of the required information. So there you go, I've just added the remaining bit of code. You can take a look at it. So here this part is the question. Okay, and here is the retrieved chunks. We're going to make it the for in loop. So we're going to say for chunk meta as well as the distance in your zip of your chunk metadata as well as the distances. Show the page meta, this is the score, and this is the chunk value. And this is the context we are trying to build. We are trying to implement with the help of this line. And next we are trying to implement the prompt part, which is going to say answer the question using only the context below. Always mention the page the answer came from. If the answer is not in the context, say I don't know. So context is being passed over here, and the question is going to be equals to question. Alright, answer is going to be equals to your response.client.chat.completions.create. We're going to use a model that is GPT-4o mini, and these are the messages. That's the role of the user. Content is going to be prompt, and I'm just printing the answer whatever came back with the help of messages.content. Okay, so that part is done. So now the main execution is going to happen over here. That is, we're going to check if underscore name is going to be equals to your main. Then over here we're going to say collection is going to be equals to index underscore PDF of your PDF path. This is the one. Next over here I'm going to say ask, call the function ask that's already defined. Here we're going to say collection, and I'm going to say what is the main topic of this document. Next I'm going to say ask collection. What are the key points mentioned? So what are the key points mentioned? Okay, that's it. Let's try to save the file. So alright, I've just pasted in my PDF. That's my resume itself. You can try to add a different PDF that is a long one as well, but this is a single page resume. Just for testing, I'm using this itself because I don't have any PDF that's handy. Okay, so just use this and just try to update the path. Make sure it's in the same folder as step 2. So I'm going to cd back and then cd step 2. So here we also need to change the questions because this is with respect to a different document. So here I'm going to say, what projects has Sujan worked on, and what skills does Sujan have? These are the 2 questions I'm going to ask. Let's see what exactly is going to happen. Okay, so here I'm going to say python 3 rag pdf.py. Enter. So I think some issue with respect to the chunk text, that's where it's coming from. Yeah, so this was a change over here. That's for chunk text. You can take a look at it. So it should be chunks.append of chunk. Okay, so yeah, make that change. Let's see if at all there is any other issue. Okay, yeah, there is some issue on line 65. Yes, I can see that over here. Okay, let me just check my previous code. That is index PDF. Okay, I missed the for function over here. So we need to say for chunk in chunks. Then we need to check the length. So yeah, that is missed out. That's the reason it's erroring out. So yeah, this loop was missing out entirely. So yeah, just try to add the for chunk in chunks and then let's try to execute it once again. And boom, just like that, we have all of the correct results. It says extracted text from 1 pages, embedded batch 1, that is 10 chunks because it has only 1 page, and done indexed 10 chunks from this PDF. So yeah, for what projects a student worked on, it's going to give the proper details. You can take a look at it. You can upload your own resume and then you can try it out with a different PDF as well. And even for the last one as well, it's going to give the proper one. Okay, so yes, that's it. It's working properly fine. So this was a simple learning to do that is in the terminal itself, and that is how RAG works. It takes an external document and you feed it to the AI and you ask the questions. So the LLM doesn't hallucinate and then just doesn't give a random answer out of nowhere. It's gonna refer to the context we have given, that is in our case all of this, okay, the document basically, and it's gonna answer the question. Okay, so that's pretty much it about this tutorial and this program. Now let's go ahead and then build a simple kind of backend and front end with Streamlit, and let's try to implement it as well. So now we're gonna build the final application, that is with the help of a simple UI. So we're going to make use of Streamlit basically, and we're going to be implementing this. That's going to be the final part in this tutorial. With the help of this, you should be able to understand what exactly is RAG, and you should be also able to code it on your own as well. So this is going to be the final program as I had said. So let's press on env and then new file. So here I'm going to say step 3. Okay, so within that we're going to have 2 files, that is going to be your backend as well as the front end part. So your backend is going to be with your FastAPI, and your front end we're going to use the Streamlit UI. It's pretty simple, so that's the reason we have picked up that. So let's create 2 files, your backend.py and frontend.py. Let's first of all complete writing the code for the front end, and then we can look into the backend part. So here we're going to have the Streamlit chat UI. So we're going to run the Streamlit run frontend.py once we have finished writing this, and also we need to make sure the backend is running. Okay, so first of all over here I'm going to import the required things. I'm going to say import Streamlit as st, that is the short form. I'm also going to import your requests. Okay, this part is done. So Streamlit, as most of the people know, this is the library used to create the UI. You can use it for buttons, text, sidebar, file uploads, and so on. Okay, and requests is used to make a API call to the backend. That's the reason we have imported these 2 things. Let's also try to initialize the backend URL over here. So backend underscore URL, it's going to be localhost. So http/localhost 8000. Okay, so this part is done. So now next let's try to initialize the page configuration. So for that I'm going to say st dot, we do have set page config. It's basically going to have a page title that's going to be chat with your PDF or PDFs, just like this. Next you're going to have your page icon. That is going to be the icon. I'm going to get that. You can use your emoji and then you can add it over there. Apart from that, we're going to have your layout. I'm going to say it's going to be wide. Okay, that's it. So the configuration part is done. The next one is going to be for the st title and the st caption. I'm going to get that. So there you go. I've just entered the icon over here as well, and over here I've set the title as well as the caption. That's going to be powered by RAG and then Retrieval Augmented Generation. So this part is done. Next, let's try to initialize the sidebar, that is for uploading the PDF part. So here I'm going to say with st dot your sidebar. Here I'm going to say st dot, we do have the header method, use that. This is going to say your documents. Okay, next we're going to say uploaded underscore your file is going to be equals to your st dot file uploader. Here we're going to say upload a PDF. It's going to take in the type, that's going to be of PDF, just like this. And it's going to have a help option that is going to say upload any PDF and start asking questions. That's it, this part is done. Next I'm going to check if your uploaded file is present. I'm going to check if your st dot your button. Okay, I'm just going to add it over here just like this. So this is going to basically create the big button, and we have passed in the ingest PDF, and the type is going to be primary and use container width is going to be true. Okay, so this part is done, and over here we're going to say with st dot spinner. So this is basically our loading spinner. So without the spinner, user thinks the app is frozen. So here we are just adding the spinner, which is going to say reading, chunking and embedding your PDF. This part is done. Next, the next step is to send the PDF to the backend part. So let's go ahead and then do that. So here I'm going to say if your, okay, not this, below this itself we need to initialize the response part. I'm going to say response is going to be equals to your requests dot post method. It's going to be a backend URL / ingest. That's the endpoint which you're going to write in the backend.py folder. So it's going to take in the files. That's going to be basically your file, uploaded, okay, not over here, upload underscore file dot your name, okay, comma your uploaded underscore file. Here I'm going to say application / your PDF. Okay, so here I'm going to furthermore check the condition stating that if at all your response dot your status code is equals to 200, which is a success status code, then I'm going to say data dot response. Data is going to be equals to response dot JSON. Okay, I'm going to say st dot success. I'm going to show a print statement saying that done, added the data chunks, and I'm also going to show the st.info. If not, I'm going to show error message saying that something went wrong, is the backend running. Okay, that is going to be just like this. Okay, I just added these two statements, and this is for the error statements. Next, I'm going to use the divider part, that is going to be st.divider. That is going to be something like a horizontal line separator. That's it. So here I'm going to add it. That is going to be this one. So next we are going to show the database status. I'm going to have my try block over here. I'm going to say status is going to be equals to your requests dot get This is going to be your backend URL. Okay, and just forward slash dot your JSON. Next, I'm going to say your st.metric. Here I'm going to say chunks in database. And here I'm going to say your status of your total chunks, total underscore. So this is just for the database status check. It may return total chunks like 120. That's the reason we have passed it over here. Okay, this part is done. We also need to pass in the except block over here. st dot your error message. We're going to say something like this and make the changes. Here I'm going to say backend is not reachable. And next I'm going to say, yeah, I think this is enough for now. Again, we can use the divider bit over here. So this part is done. Next is going to be the main chat area. First of all, we're going to store the chat history in the session state. I'm going to say if your messages not in st dot your session, session underscore state, then here I'm going to say st underscore session state dot messages is going to be a empty array. Next, let's try to render the existing messages. I'm going to say for msg in your st dot your session state, use the same thing again. I'm going to say with your st dot your chat underscore message of your message with respect to the role. Here I'm going to say st dot write of message of your content. Okay, so this statement over here is super important because normally Streamlit actually reruns script every interaction. So without the session state, the chat is gonna disappear. So we're gonna just store the chat history, something like a pretty simple memory. Okay, and next over here we are trying to use the for loop, that is to render the older messages. Okay, we're gonna loop through the previous messages, and this is for the chat message UI. Okay, that's the reason we've written that. So yes, that's it. And here this is to show the message, that is st.write of message of content. So next I'm just going to show the sources, that is only the assistant responses have sources. And I'm also going to show the expander as well, that is going to be the collapsible section that is used to show the retrieve document chunks. Okay, so that's just like this. You can take a look at it. So this part is done. Okay, so now next step is to handle a new question. So let's try to go ahead and then add it over here. So here I'm going to say if your question is your st.chat input, that's going to be ask anything about your documents. Okay, so here we're going to show the user message. I'm going to say st dot your session state dot your messages dot use append method. Here pass on the role, that is going to be with respect to the user, and your content, that is going to be your question itself. Furthermore, here I'm going to say your width st dot your chat underscore message with respect to the user. Here I'm just going to write it over here. I'm going to say st dot write of your question. Okay, so this over here basically is going to create your chat input box just like your GPT. All right, so here this is known as your walrus operator, that is colon and then equals to. So this means it basically gets the input and also assigns it to a variable, that is question, and also checks if it is non-empty, all in one single line. So here we're trying to store the user message with the help of st.session state, and we're also going to show the user message with the help of this piece of line. Okay, next we are gonna have the assistant message container. So this basically creates the assistant response bubble, and we're also going to show the loading animation as well. Okay, so I'm just going to add that over here just like this. Next it's going to be calling the backend code. So here I'm going to say try, I'm going to say response is going to be equals to access the requests. It's going to be .json, request dot post method. It's going to be a backend URL. We're going to have another that's going to be ask, that is backend URL / ask. Okay, and JSON is going to be equals to question, that is going to be question itself, and your n underscore results is going to be n underscore results. I think we need to define this, it's not yet defined. We're going to do that in just a bit. Okay, so once we have the data, let's try to access that. Data is going to be equals to your response.json. Okay, next I'm going to check if at all we do have the error over here in data. Then I'm going to say your answer equals to data with respect to your error, and your sources is going to be empty array. Else over here I'm going to say answer is going to be data of your answer, that's how we access it. And else we're going to say your sources equals to data of your sources. That's it, this part is done. And once this is done, we're also going to have the except block as well, that is except exception as e, which we're going to say could not reach the backend, and sources we're going to set it to be 0. And we're also going to show the answer as well with the help of st.write of answer. Okay, that is just like this, you can take a look at it. And this part is for your network error handling. It handles the backend down and internet issues as well as the invalid response. Okay, so this part is done, and this is to display the answer as I told. So now the next step is to show the sources again, that is it's going to display the retrieved chunks. This is the RAG explainability, that's super important in production AI applications. So let's try to show the sources part. I'm going to add the code for that, and also to save the history with the help of session state.messages.append. Alright, so that's pretty much it. I've just added the remaining part. You can take a look at it. So just let's try to save the file. You can take a look at it from the starting point if at all you've missed something. And this is the last part added, that is to append the answer, and this is to show all of the sources, that is to check the view retrieved chunks. So that's pretty much it. Let's create a new file. Yes, already created. So here let's start writing all of the methods. So we're going to have two routes, that is / ingest, that's going to upload a PDF, chunk it, embed it as well as store it. Next you're going to have a / ask, that's going to ask a question and get a grounded answer based on the context. Okay, and we're going to run it with the uvicorn method. Let's try to say import OS and import fits. Then from OpenAI I'm going to say import OpenAI. Then from .env import load_.env. Then from FastAPI I'm going to import your FastAPI, your upload file, your file. Then from your FastAPI .middleware part. Okay, we're going to import .course as well. I'm going to import course middleware, and we're going to use pydantic. So from pydantic we're going to import the base model. Final import, it's going to be for the temp file. That's it. Let's try to use the load.env over here, and let's try to initialize the client code as well. That's going to be this one, to load it from your env file, just like this. Okay, here I'm going to say app is going to be equals to your FastAPI, include that. It's going to ask the title, that is going to be RAG API. here I'm going to say create the instance. Yeah, that's already done. And app.add_middleware. I'm going to say your course middleware. So I've also added the star for everything, that is allow origins, allow methods, as well as the allow headers. That's okay. Next is for the shared ChromaDB client. Let's try to again create a persistent one. I think we've already done that. Yeah, similar code. Add it over here. So we're going to say chroma_client is going to be equals to ChromaDB dot persistent client, and path is going to be this one. So I think we need to import your ChromaDB as well. That is just like this. Okay, so here we're going to have the next function that's going to be defined get or create a collection. So that is going to be basically a collection helper. So its main purpose is going to be if at all collection exists, we're going to get it, else we're going to create it. I'm just going to add a simple Python function get or create collection. So we're going to say return chroma client get collection for the rag collection, else create collection of the same name. That's going to be your rag collection. So this part is done. So now the next step is to initialize the chunk settings. That is to add the chunk size as well as the chunk overlap value. So I'm going to say chunk underscore size equals to 500, and chunk underscore your overlap is going to be equals to 50. Okay, so why does chunking exist? Because LLMs cannot process huge PDFs directly, so we're going to chunk the document into different sizes, that is small chunks. That's the reason we've entered the chunk size as well as the chunk overlap. Overlap means it chunks the overlap by 50 characters. Okay, so this part is done. Next is to extract the text from the PDF. Okay, so for that we're going to have one more function. So let's try to define the extract text. I think we've already written this function previously. It's going to be similar itself. I'm going to say define extract underscore text of your PDF underscore path. So this is going to read the PDF. So here I'm going to say doc is going to be equals to your fits, use that package, dot open of your PDF path. Okay, so next we're going to store the pages. So pages is going to be equals to a empty array. Apart from that, I'm going to make use of my for loop. So for I comma page in enumerate of the doc. Here I'm going to say text is going to be equals to page dot get underscore text dot strip. Okay, so this is basically to extract the text from the page, and we're going to ignore all of the empty pages as well. I'm just going to write out the function that is just like this. So this is for the storing part. We're going to store all of the pages within the pages array, and we're going to say doc.close. This is very important because it's going to prevent the memory leaks part, and we're trying to return all of the pages. That's pretty much it. So that's what your extract text does. It's going to extract the pages, that is text, and it's going to store it into the pages array. Okay, that part is done. Now the next step is pretty simple. Again, chunk the text. I'm going to add it for that. I'm also going to add it for the embed text as well. I'll be explaining what exactly is happening. We've already written this function. That's the reason I'm just going to add it over here. So there you go. We have two more functions, that is chunk text as well as your embed text. So chunk text, as the function itself suggests, it's going to split larger text into smaller chunks. So we have initialized a chunks array that's set to 0. Start value is 0, and we're going to start the loop, that is keep chunking until the end. For that we've used the while loop, and we are trying to create the chunk with the help of the append method. Okay, we're going to say chunks.append, and we're going to initialize all of the chunks. So this is the way we do Python slicing, and this is your, you can call it a move window. This creates the overlap part. So we're going to say start plus equals to chunk size minus chunk overlap. I think we have done this previously, and we are trying to return the chunks. That's it. The next one is going to be for the embedding function. Here we have defined a function that is embed text of the text. This is basically going to convert the text into vectors. That's what embedding does. Okay, so for that I'm going to say client.embeddings.create, pass on the text that's going to be in the form of input, and we're going to use this model that is text embedding 3 small, and we're just trying to return the embedding over here. That's going to be in an array of numbers. That's it. So yes, this part is done. So now the next step is to define the routes. The first route we're going to have is the ingest route. So here we're going to say add app dot, it's going to be post method, and it's going to be /ingest. Okay, it's going to have async method, define ingest. It's going to have a file that is going to be upload file equals to a file, and here we're trying to save the uploaded file to disk, that is temporarily. That's the reason we've written this. So we're going to say with temp file.named dot temporary file, later is going to be false, and suffix is going to be dot pdf as temp. So here within this I'm going to say your content is going to be equals to await your file dot read, your temp dot your write of your content. I'm going to say tmp underscore path is going to be equals to tmp dot your name. Okay, that's it. So once that's done, here I'm going to say initialize your collection part. So collection is going to be equals to get or create, call that function. That's it. So if it is present, it's going to retrieve that. If it is not present, it's going to create. That's how the function works. Next step is simple. We need to extract, chunk, and then embed. So pages is going to be equals to call the function extract text of your tmp underscore path. Here I'm going to define all of the methods, all of the variables, all chunks, all metadata, as well as all IDs. So let me just add it over here. And I've also initialized the chunk index equals to collection.count. So this is to continue from the existing chunks. That's the reason we've written that. So now next, let's try to loop through the pages part. So for that, I'm going to say for loop. I'm going to say for page underscore number, comma page underscore text in pages. That's how your for loop goes. I'm going to say furthermore, let's loop through the chunks. I'm going to say for chunks in chunk underscore text of your page underscore text. So this is for the chunk page. We are going to skip all of the tiny chunks. So for that, check the condition first of all. That is, if your length of your chunk dot strip is less than 50, I'm just going to say continue. Okay, else over here I'm going to say all chunks dot append of chunks. Okay, my bad, this should be chunk, not chunks. So next I'm going to say all underscore metadata dot append. It's going to have the source as well as the page, so it becomes important, or it becomes easier for the user to understand from which file or from which source it's coming. It's going to be file dot file name. Next is going to be with respect to the page, that is going to be your page underscore name. Okay, that's it. This part is done. Sorry, page underscore num, not name. Finally, all IDs dot append. Here it's going to say your chunk underscore your chunk index, and here increase the chunk index equals to 1. So this is to store all of the chunks, and this is for the metadata part. It's important because this enables your source tracking and the citations. That's the reason we always use this. So this part is done. So now the next step is we're going to embed in batches, because it's more efficient and it is going to avoid your API overload as well. I'm going to add the code for that. Okay, so initially we're going to include your all embeddings equals to or empty array. Make use of the for loops. So this is basically going to process 100 chunks at once. That is the batching part. That's what I explained. Okay, and we're going to get the batch. That is how we get a single batch over here, and this is to embed a specific batch, and you're going to store in ChromaDB, and this is how we do it. All right, so what gets stored in ChromaDB? Your chunk text, your embedding vector, your metadata, as well as your unique ID. And next, you're also going to delete your temp file. So for that, over here, I'm going to say os.your unlink of your temp underscore path. That's it. So we're going to return the response. That's going to be the next step over here. So this is just going to have a normal message that is going to be your ingested file name, that is with respect to that particular PDF file, your chunks added, your length, as well as the total chunks. This part is done. So frontend is going to receive all of this information. This part is complete. So now let's move on to the next part. That's going to be for /ask. So here we're going to create a request model for that. Okay, so here I'm going to say class ask request of your base model. So this defines the expected JSON format. Okay, so first of all over here I'm going to say question, that is going to be in the form of string, and your n underscore results is going to be int, that's going to be equals to 3. Let's try to write the method. I'm going to say add app.post, it's going to be /ask async method, define ask, it's going to have a request of type ask request, that's the one which we have defined above. Let's write async properly. Here again collection is going to be equals to get or create collection. So here I'm going to check the condition stating that if at all the collection dot your count is equals to 0, then here I'm going to say return error, no documents ingested yet. Okay, upload a PDF first. This part is done. Next is to embed the question as well. So question underscore embedding equals to your embed text, call that function, it's going to be request dot question of your 0. Next is simple, we're going to search for the nearest chunks and we're going to get all of the chunks. So this is going to be the vector search, that is we're going to say request is going to be equals to collection.query. This is the most important, your rack step. So what this does is it finds the chunks similar to the question we have asked. Okay, the parameters this is going to take is your query embeddings, that's your question vector basically, and n underscore results, how many chunks to retrieve, in our case 3. Okay, and it is also going to include your documents, metadata, as well as your distances. That's the reason we have passed on this include. Once that is done, this is how we take in the results from this particular results. We're going to say chunks equals to results of documents of 0, metadata is going to be equals to results of metadata of 0, and your distances is going to be equals to results of distances of 0. Next part is simple, build up the context and then we'll look into what exactly we're going to do. So here I'm going to say context underscore parts, it's going to be equals to, so this will combine chunks into one single prompt. Okay, I'm also going to say sources is going to be equals to empty array as well. So next for chunk, so we've written the exact same code that is in the previous program, that is in this form of for loop. So in zip of your chunks, comma your metadatas, comma your distances. Here we're going to say context underscore parts dot append of chunk. Okay, and I'm also going to append the metadatas as well, and I'm also going to create the context as well. Alright, so that's it. I've just added your context. This is how we create with the help of join. We have done that previously, and this is your prompt. Initialize the context. The question is going to be request.question. Again, response, initialize it from the previous program. It's going to be the exact same thing, no more changes, just like this. And try to use the print to show the result. Okay, not print in this case because we're returning it to the front end. So return the question. Answer is going to be response.choices of 0.message content, and sources is going to be equals to sources. So that's the second endpoint. We've completed that, and the final one is to get the health check done. That's going to be done with the help of this. I'm going to say add app.get of / define root collection is going to be create that, and this is the return statement which is going to say state is running, total chunks is going to be equals to collection.count. This is just a health check endpoint. So we are done with this. So let's say we are going to go into your cd step 3, and we're going to run the command that is going to be uvicorn backend app reload. So uvicorn backend app hyphen reload, enter. Let's see what happens. There you go. Just like that, it's working properly fine. Application startup complete, waiting for application startup, and started server process. It is running on this one. You can also check out the local docs, that is localhost 8000/docs. You should be able to check the FastAPI in the backend directly. And boom, just like that, as I told you, we have two endpoints. Just head over to this particular link, that is localhost 8000/docs. So you can also test out all of the endpoints over here. That is, you can test it out in this particular button itself. That is for each API. You can press on this, try it out, and you should be able to try this out. Okay. So now let's run the front end part. Backend is working properly fine, and it gives a unique documentation for each of the API that we have built. That's why FastAPI is pretty good to use for beginners. So here, for the front end part, it's going to be simple. You're going to use the Streamlit command, Streamlit run frontend.py. That's the command. So cd step 3, here I'm going to say Streamlit run your frontend.py, enter. There you go. Just like that, we have a good simple UI that is done using your Streamlit. And as you can see, it says chat with PDFs powered by RAG, Retrieval Augmented Generation. Here we can try to upload it over here. Okay, let's try to upload it over here. So I'm going to upload my resume, basically the same resume I used in my previous program. Just use this, open. And once I press on ingest PDF, it should work and it should call that endpoint, and let's see what exactly happens. It should chunk, embed, and it should store in the ChromaDB as well. Ingest PDF, and boom. Just like that, it says reading, and just like that, it showed reading PDF, chunking, and done. Added 10 chunks, total in database 10 particular chunks. So now we can actually try to chat in your input box based on this particular documentation. So I'm going to ask the similar question, that is, what projects has Sujan worked on? Let's see if at all it can give all of the correct results based on my resume. I'm going to press on send, and boom, it is saying searching your documents. There you go. Just like that, it's retrieved all of the required context and the proper result. Yes, this is the correct answer based on my resume. It says Sujan has worked on a full stack dating app designed and developed as a seamless user experience inspired by Hinge. It was built using React Native for the front end, Amazon AWS for the backend services, and Socket.io for the real-time messaging. Source is going to be the context, and you can also view the retrieved chunks as well. And boom, just like that, we do have from where exactly it is retrieved. So since we have only one PDF and we only have page 1, it is retrieving from that, and it's also able to show all of the information as well. Okay, with the similarity score that is given over here. We can also try to, let's say, enter a different question. I'm going to say, what skills does Sujan have? Let's press on enter. It is searching your document, and there you go. Just like that, based on my resume, whatever is present in that particular page, it has given all of the skills. And again, we retrieved chunks. It's going to be similar because we have only one page, and all these scores are going to be different. So you can also enter a PDF that's going to contain large number of pages, and then you can ask the questions to it as well. Okay, so you can ask a different question as well. Let's say something that's not there over here. What is the return policy of my company? So since it doesn't have this information in the document, and we have specifically mentioned in the code stating that if all do not have any answer with respect to that particular question in the context, then just say I don't know based on the provided documents. So it should say that same thing. So let's say enter, and just like that, it says I don't know based on the provided documents, because if all it was a LLM, it would have just given a random answer out of nowhere with a random return policy of some random company. That's obviously wrong. Okay, so with the help of this RAG implementation, we are going to provide context to it, and based on that context itself, it's gonna go through that particular context and then give the proper results. And if at all there is no answer to that particular question asked by the user in that particular context, and it's directly going to say don't know based on the provided documents. Okay, so that's pretty much it. So I hope you understood about this RAG tutorial. That is, from scratch we implemented it and we understood what exactly is RAG, what are vector databases, what is ChromaDB, what are embeddings, how is it going to be stored. Okay, and if you find this interesting, please hit the like button and do subscribe for more such videos and more such content as well. So yes, that's it about this tutorial. Let's see you in the next one, and then thank you for watching.